So now that we looked at the very simple example of EX0, let's turn our attention to the next somewhat less simple example, but it's still pretty simple, called EX1. And this example shows how to use Java Lambda expressions and method references, which are two key functional programming features, to create a closure. We'll talk what that is in a second, as well as to show various ways to sort elements of a collection or in a collection using Java anonymous inner classes, Java Lambda expressions, and Java method references. And it also shows how to use modern Java features like the forEach method for both streams and collections. And oddly enough, they're not identical, which is kind of cool. So here's the main program. You can see here that the main program is going to start out by running the closure example. We'll look at that one first. And then we go ahead and demonstrate a bunch of different ways of sorting and printing an array using various Java functional programming techniques. So let's start off by looking at the closure example first. So the closure example is a class. It's a nested class. It's a static nested class. And it's got one field, which has type int, and it's mres for mresult. I typically like to use the system form of so-called Hungarian notation because I can tell at a glance when I look at the code whether something is meant to be a member or a field as opposed to being a parameter or a local variable. There's other types of Hungarian notation which I don't like at all, but I like the system form, so you'll see that a lot. If you ever wonder why it's called Hungarian notation, it's named after Charles Simonyi, who was one of the early members of Microsoft's technical staff, and he was Hungarian. So he's the one who came up with this naming convention, so it's called Hungarian notation. Down here, we have a factory method called make thread closure, and it's passed a string and an integer n. And you can see down here, here's the call to it in this closure example constructor. We say make thread closure, and we pass in the string, which is result equal, whatever it's going to equal. And then we pass in n, which is the value 10. And what make closure does is it creates and returns a new thread object. So we make a new object of type thread whose runnable Lambda expression, this guy, defines a closure that reads the method parameters. So in this case, that would be string and n, and uses them as the runnable that's passed to the new thread. So we're making a Lambda expression that's going to be used to create the runnable that the new thread will run when it's started and its run hook method gets called. And the other interesting thing here, just to show how you can do this stuff with streams, mres is a local field in the closure example class. And you can actually update the values of local fields within the context of Lambda expressions. You can't update the value of the string parameter or n, which is the int parameter, because those parameters are treated as what's called effectively final. And the videos for the class talk about effectively final. Effectively final is basically a variable that's going to be set to some value, in this case, bound to the parameter passing mechanism, and then not changed up to the point where it's accessed. So you can't change parameters, but you can update or change private fields like mres. So we make ourselves a new thread. We get that thread. We start the thread. In a real program, we'd probably do something else at this point. Just go ahead and join it. And that will go ahead and start the program to run. It'll go ahead and print the results out. And that will show up as result equal, and then it'll be mres plus equal n. So you can see what that looks like when we run the program in a second. We also have another name array. This time it's a final static private field in the overall EX1 class. And just for kicks, we define ourselves a supplier. A supplier is a functional interface that's defined as part of modern Java. And what it does is a supplier has a single abstract method called get. And when that method is called, it will do something. In this case, it's going to make a copy of the array that's passed in here. So that's what we're doing. And you'll see how this gets used in a second. So down here, we're going to take that name array and we're going to first start off by printing it. And then we're going to go ahead and make copies of it and pass them into these other methods, show inner class, show Lambda expression, and then two variants of show method reference. So let's go ahead and look and see what those methods do. They all take in the name array. And what we're going to do here is we're going to use the sort method defined on the arrays Java utility class. And we're going to show different ways to sort things. The first way we're going to do it is kind of the bad old way of doing things, where you use the Java anonymous inner class syntax. And you can see it's rather verbose and very verbose, actually, and ugly. And what it does is we have to say new comparator string, and then we define the compare method, and it says string s, string t, and then we say return s to lowercase compared to t lowercase. So that's kind of the old school way of doing things using the anonymous inner class syntax. Very crufty. If you find yourself writing code like this, it's probably a sign that you haven't popped into the modern Java paradigm yet. So let's go, speaking of modern Java, let's go take a look at another way to do this. So another way to do this is to have the same parameter passed in, namely an array of strings, but this time to do sorting using a Lambda expression with so-called type deduction. And if you take a look here, we say sort name array, comma, open paren s, comma, t, close paren, arrow, s, compare to ignore case. And so this obviously is a lot more concise. And that part of the reason why it's so concise is it's using what's known as type deduction. If we don't like type deduction because we think it's too clever for its own good, we can expand this automatically and turn it into the actual types, the non-deduced types. But type deduction is a nice feature. So this is basically going to go ahead and take s and t and compare s to t while ignoring case. So it's more concise. Now let's go ahead down and take a look down here at a couple of ways of using so-called Java method references to do the same thing. And this is what I love. This is my favorite way of doing this stuff. So here we're going to say arrays.sort, the name array, and then we say string, : compare to ignore case, which, as you can see, is a lot more compact than the code up here. In fact, our IDE is trying to signal to us to replace that verbose Lambda expression with a method reference. So that's a good thing to get in the habit of knowing. And in fact, I think if we probably come up here and we select the anonymous inner class and we get lucky, let's see, yeah, it didn't know. Oh, here we go, replace with Lambda. So we can replace that with a Lambda. And now, because of the way I did this, it doesn't know enough to be able to replace it with a method reference, but we saw how to do that down below. So this approach uses a method reference instead of a Lambda expression. And then, just for kicks, it uses the stream of factory method to convert the name array into a stream. And then it uses the forEach terminal operation on that stream to print the contents out to the standard output. And the next method down here does pretty much the same thing, but instead of using stream of to convert the name array into a stream, it uses list of to convert the name array into a stream. And then it uses the forEach method on list, which is actually something that is inherited from the iterable interface. So these are just showing you different ways of doing the same kind of thing. Believe it or not, there actually are some differences between forEach on a stream, which is what we see up here, and forEach on a list or an iterable or a collection that we see down there. And I won't go into that in great detail now. That is covered in some of the asynchronous videos. So armed with all that, let's go ahead and run the code. You can see here now that it basically goes ahead and prints the results of the closure. That was the first thing. And then it prints the original array. And then we sorted everything a couple different ways and just shows the output for all this stuff. And just take it on faith that the output is indeed correct. So this example just shows, again, a couple of simple features that are kind of fun with Java and modern Java, and demonstrates how you can go from anonymous inner classes, which is the bad old way of doing things, to Lambda expressions, which is a better way, and in some situations to full-blown method references, which are very concise. Those of you who are familiar with C++ might see the resemblance of the method reference syntax to what C++ would call static pointers to member functions, or pointers to static member functions, or pointers to non-static member functions, and so on. And it's very similar syntax for much the same benefit. It's a very concise way to pass that information around.